decided to write something for myself to help me solidify the things that I already know or I understand, and also hopefully help others understand things better as well. Now, guidelines, if you look at a lot of other languages, there's notably for Python or C++, JavaScript, there's guidelines around those languages, and they've developed tools to enforce these guidelines when people are developing projects. But for Qt and QML, these guidelines, even though the Qt official Qt documentation is great, the information is scattered around multiple places, and it's really hard to pick the correct information from that. Sometimes there's a great information that's hidden in a long text for a property documentation, for example. So it's really important to get all this valuable information in one place and help other people find it and structure it in a way that serves as a specification for future tools that can be implemented around it. And for QML, there's already a tool called qmllinter, which was initially developed by KDAP for Qt 5.4. It was introduced in Qt 5.4, but it only has simple checks. That's for syntactical, and recently with Qt 5.14, they've introduced a check for unqualified identifier checks, because that is going to be deprecated in the future versions. But essentially, those are the only two things that qmllinter check for. Even though Qt Creator provides a lot of tools for you to write your QML code better, including code completions and highlighting and certain context-dependent information about the availability of a property. But not everyone is using Qt Creator, and especially when you start working on a big project, there will be a lot of developers with different tools. So having a linter enables better opportunities for people to integrate them into their own development workflow and into Git hooks or into continuous integration environment. For example, at Autodesk, we're using qmllinter as part of the Git hook process, but since it only does statistical checks, it prevents certain errors from happening. Now, in order to enable all this information, all this tooling, there's a certain amount of work that needs to be done before this can be done. And there's already work being done by the Qt developers, and these are the related work that you can take a look into. They're really good places to learn more about QML tooling and understand, get more insight into it from the developers who are developing it. So I highly suggest that you take a look at those tickets on Jira. Now, I want to talk about I'll only go into certain a few items from the guidelines. I won't have time to go over all of them. And it's important to note that these guidelines are tailored to my preference working on the projects that I've worked on. But there's one shout out that I want to give right now to Mitch Curtis. He did some initial reviews on the guidelines, and I've incorporated some of his ideas into the guidelines as well. So let's start with the code style. And when I think about QML documents, like this code style obviously exists in other languages about the way you include things or import things and the way you name things. And Qt provides certain information about this in the official documentation as well, but I find that I don't agree with it at some points. So this is the list that I've come up with. And one of the things that enable for me is seeing the QML document, the QML component in a better light, because I think of a QML type or an item as a visual item. So when I look at the code, I like to be able to visualize that to kind of expedite that prototyping process for me. And I find that if you're able to look at a QML document and be able to visualize it in your mind, it is a pretty good indication of a clear and well-written code. And in order for that, I find that starting with the obvious and the most fundamental properties are the way to go. So as you can see here at the very top, we have the ID that identifies the type, and then the property, the custom property, and signal declarations. For these, I'd like to go into details later, but then all of these assignments at the top start with the custom ones and then go to built-in, and then start with the child objects as for visual items. And the reason for that is I consider the custom ones as part of the main interface of the QML type, because there's already documentation available. People have a certain sense of what a type provides for built-in ones. But for custom ones, when I'm using a component that was written by somebody else, if I want to learn more about it, I just go to the file, and the top of the file is the first thing that I see. And most of the times you're only interested in what you see at the top, because the signals, the custom signals and the properties define the interface of that type. And for child objects, I like to see the visual items first and then the non-visual ones second, but then they go from the visual, the non-visual ones starting with the Qt provide built-in ones and then the custom ones. And in order to provide better encapsulation for QML code, I've come to started using Qt object as a good encapsulation for this, but with Qt 6, they are adding a private keyword for property declaration, so that will no longer be necessary after that. And the last one is the JavaScript functions. To go into the details for this, I'd like to explain the reasoning for that, because as part of that, the interface, when you look at it, this, for example, the assignment and the declarations in this code is all garbled up in arbitrary order. So when I look at it, it's harder for me to see things clearly. But changing that code to conform to the guidelines that we have, it enables a better reading experience for it. And when I look at it, it's easier to see the custom interface that's provided, and having the on completed and on destruction signals at the bottom is it's just something that I find useful, because mentally I picture uncompleted handler to happen for, the last in the chain. So it just reads, that reading flow works better for me. My eyes go from top to bottom, and by the time I reach the bottom, I've already learned a lot about the properties of the item, and I now know what's going to happen at the end of all that execution. And when it comes to private property assignments, there is a certain order that I'd like to follow. Like I mentioned, the fundamentals of a type for me is looking at for visual types, looking at the geometry information. Like that, to me, those are the basic information about a visual type. And if I don't see those at the top, it becomes harder to engage in that visualizing process, because the building block of it, the first block, is missing. And when we fix that code, you see that when I look at it, I know where it's going to show up in my imaginary scene, and I know the size of it. I know the anchors, if there are any, and all those information I can compile that, if you will, in my mind and see the result without having to actually run the code. And when you have especially when you have a large code base, this becomes very important, because there's a lot of context switch that you're doing from one component to the other, and having a reliable way of looking and reading the code makes things a lot easier. And another alternative for this is using this grouping syntax that some people use. I usually don't use it, but this is also something that I added in the guidelines to help other people. This might be intuitive for some people to see X and Y at the same level. And the last one that I want to talk about is the functions, the JavaScript functions that we implement in a type. And for these, I can't remember the exact order in the official documentation, but it's either the third or fourth in the order. And to me, it makes it, when I look at the code, it starts from the root. It's a visual tree. So starting from the root to the child objects, if there's anything obstructing that view for me to go from the root, the parent, to the child objects, it makes it harder for me to read the code. So having these at the bottom helps me understand better, because when you look at a file, like I said, you go from top to bottom, and by the time that you've reached the bottom, you've already familiarized yourself with the properties and the state of that type, And at that time, like set custom source makes a lot of sense. So if we fix that code, it reads better. And in large code bases, for example, at Autodesk, we have in that a lot of QML files and big files sometimes, and going through this, knowing where things are, even makes the navigation of the code easier. And the other one is import statements. This is pretty standard in other languages as well. Include statements in C++ and Python. In Python, import statements go in a similar order as well. This is all garbled up. It's an arbitrary order, but when we fix that, it goes from the built-in Qt provided imports to third-party ones, and then the local C++ modules, the local QML modules, and local imports. This really doesn't have any technical reason for it. Like I said, most of these, the first section about the code style is about the readability of the code. Now, one of the great things about QML is the binding mechanism that they provide. And it's super useful and powerful, but there are certain common problems that we have with it. And it's usually the binding loops or binding removals. And both of these things usually mean that there is going to be a bug in your code base. Now, one of the things that you can use to solve those problems is using the binding object. This binding object provides a way for you to construct binding expressions on arbitrary properties. For example, in this case, we have a top-level rectangle, and we're binding red and yellow colors depending on the pressed property of mouse area on the rectangle's color. Now, whenever the mouse is pressed, the color will change. And even when I click on the button in the middle here, this section, and here you can see that we're actually doing an imperative assignment to the color, but because of the binding object used here, this will not break the binding that we have here. So even after clicking the button, the rectangle's colors switches to pink, but when I press the mouse area again, the binding will work and the rectangle color will still turn to red. Another good and a bit more complicated example for this is having kind of two-way bindings for this. In this case, the rectangle's color depends on is bound to the color of the color dialog, and color dialog's color is bound to the rectangle's color. Now, when we show the example here, we go. If you run this, it starts with the black, and when I change the color changes, and when I start the color dialog again, it starts off from the previous color that was set. But as soon as I do a right click here, the binding will be broken and this will no longer work. In order to prevent this problem, binding again comes to our aid. With a good example, we can actually start using the binding object to prevent that from happening. And whenever we do an imperative assignment here, it will still change the color, but the bindings will still keep working. And this brings us to the declarative over imperative assignments. And this is something that's also recommended in the official Qt documentation. And it's really, I find that that declarative nature of it in QML is it's essential. It's an essential property of the language. So whenever possible, it's always best to use the declarative approach. Even if it means, for example, in some cases, it's hard to use it, and using things like binding objects can really help with that. And you can even use the when property of a binding to enable or disable that binding, depending on some condition. And using imperative assignment may have a overhead as well, since, like, as you can see in this example, the color is first initialized to a default one. And then when the initialization of the rectangle is completed, the color is changed. And the other thing with the bindings is because with each property that you declare, there is an associated change signal, property change signal. And whenever this property is written to, Qt automatically emits the signal. So in this example, if you do some expensive operation on a property, property, and then in this for loop you keep adding, or you keep changing this accumulated value in each iteration. And with each iteration, this accumulated values change signal will be emitted. And since here the text value is bound to the accumulated value, this text will each time with each iteration this will change, and it will cause a redraw. Now in this example, it may not seem like much, but when there's a lot of bindings that you have in your code, and the more complex your UI gets, the side effect of these unnecessary evaluations can get a lot and cause serious performance problems on your application. And one way to avoid this is using a temporary local variable where you do whatever operation that you need on it, and then assign it to the actual property when you're done with the operation. And you'll see that in this example that binding will only be evaluated once in effect of the accumulated value change, but it will be called twice because accumulated value will be initialized to 0 first, which will cause the change signal, and then there will be a second one for when we change the value to the temporary value. One other aspect for this is the C++ integration, but there's a lot to cover here, so I didn't add a lot to this presentation, as it would take a lot more time. But just in a nutshell, the context properties are usually bad, and they will be deprecated in Qt 6. The singletons are a better way of providing the functionality that you usually get from context properties. And the reason that the context properties was first introduced in the language was because the singletons didn't exist. And if you follow with that bug report that I referenced there, it actually links back to a mail thread that happened in 2013 and details about the bad side of context properties and the reason why you should start using singletons. And if you look at this benchmark here, this was a benchmark that I did a while ago with Qt 5.11. Using the context properties was a significant performance hit. Even though if you're using context properties, in my opinion, you should only use it to provide information from primitive types, or at least Q gadgets, and certainly not Q objects. Instantiated types are the best way to go for whatever need that you have. And the attached types also provide a good way to extend your type without having to change the interface of it. The other thing is handling signals. And there's two ways of handling signals in QML. And one is using the associated chain signal. For button, there will always be a button chain signal, and you can connect to that. You can use that with on button change. And there's another syntax that you can use to connect another function to a signal, and that's the connect method that's provided with every signal. But this is not an ideal way of doing it. First, because as you can see in this example, it's an imperative assignment. And second, this especially becomes apparent in places where you're using models and delegates. If you're using this connect function to connect to a signal and your item is destroyed, that signal connection may not be destroyed. If it's created, if the function that you're connecting to exists in another context, that connection will still exist, and you'll run into problems in your code. There's a detailed example for this in the guideline, but because of time and space constraints, I was not able to put it here. But it causes real problems when you use that syntax. And the way to fix that would be using the connections type that Qt provides. With this, you can still use the same syntax as you would when you're not connecting to a separate properties signal. And it's way more intuitive and easier to read than using the connect function, because this kind of declarative assignment is what we're used to seeing in QML code. Now, there's one caveat to using connections object. It's when, this is actually something that happened to me. When you're using the connections object, the target of it defaults to its parent. So if you don't set the target explicitly and expecting the target to be set at a later time when something happens, the default target will be the parent. And if the signal that you're listening to exists in the parent item and it actually emits it, you'll be executing code that should not have been executed. So in order to prevent that, if the target is going to come from someplace else, it's best to set the target explicitly so that you don't run into this problem. And this is for the JavaScript use, and this is not going to be about if or how much JavaScript code you should use in your application. But for JavaScript, Qt supports ECMAScript's script 7 since Qt 5.12. And I find that with it's important to also stick to the recent language features from JavaScript as well. And also one note, QML3 is likely going to have a subset of JavaScript. So I highly recommend that you keep the JavaScript in your code to a minimum. Even if you're using JavaScript, it's best to not rely on a lot of language specific features of JavaScript, but to kind of have a script as a simple function to set from one thing to another, instead of having a complex function that operates on promises and all the other language specific functions. Because if you migrate to QML3 and you want to use the subset of JavaScript, you will not be able to do this. So one thing is I find very useful in cases where you're creating a binding using the Qt.binding function, it's using the arrow syntax. With arrow syntax, even though this is not my preferred way of creating bindings, like I mentioned, using the binding type or connections is a better way for doing this. But with this, whenever you have to use it, at least the code reads better. When you look at it, it actually kind of looks like the usual binding creation syntax, because if you just remove that Qt binding there, it's essentially assigning some other value to root value, and it reads better than having that verbose syntax where you have to enter the function and curly braces and the return statement. Because of the implicit return statement feature in arrow syntax in ES6, you can just omit that part and just return the value by just referencing it. The other one is, this is very important for me because var has its own issues, and sticking to, again, modern language features always makes for a better code for your QML code as well. And in this case, using constant let instead of using var type is way better use of your time than just using var. And another thing I'd like to mention, since we're talking about types, is keeping your property assignments to strong types, because having var as a replacement for what you can actually declare as a static type is bad practice. Because in QML3, they will also, even now, they started actually deprecating some of the dynamic nature of QML language. With QML3, using strongly typed properties will be required. So I find that it's best to start using those now rather than later. That's all I'd like to mention about, even though there's a lot more content there. These are all the things that I can mention during the presentation. And as far as what's next comes, I'd really like to, so far, it's only been my personal effort, this guideline. And I believe that it should be a community effort, because all this information only comes from my experience in certain areas, but there's other people, a lot of good developers out there who are doing a lot of work on QML, but that collective information is lost, not lost, but not available to other developers, because there's not one place where you can look for this information, even though sometimes if you do a search for it, you'll come across great articles, but again, they're hard to come by. So ideally, even though there's some interest in the repository, I haven't seen any contributions yet. Mitch Curtis, thankfully, he did some reviews and it was very useful, but it'd be great to have your support to improve on that and change the formatting of it. Right now, it looks like one giant blog post, and I have plans to turn it into something else so that we can actually use it as a specification for the linters. I'd like to get to the questions now. There's a few questions before I run out of time. And one from Puya is there going to be a language server for QML? Also, any plans for a QML formatter? They are also already working on a QML language server for this. I believe they will have to implement this in 2 stages. One was, if you actually go back to the tickets that are referenced in that slide, they detail about this, and they are already working on the language server implementation. I believe that it's in development now. And as far as the formatter, this was something that I talked to with one of the developers at Qt during the last year's World Summit. Even though they don't have it now, they seem to think that it's a good idea, but I believe that will probably a part of the QML DOM implementation that they're working on now. The other question is there a QML lint from Edward? Is there a QML lint and QML beautifier that follows these guidelines? Unfortunately, no. There's only the QML lint that provides this, and that only, like I mentioned, that only does 2 checks: one for syntax checks, and the other one is for the unqualified property access check. And Kirill mentions that member functions are also part of the QML type interface. You're certainly right, but I find that because those functions are, I guess that's really for the implementer of the component, but I've always found it easier to see the functions at the bottom so that by the time I get there, I know exactly what that function is operating on. But you have a point about having it, the function being the interface as well. There's a question about elaborating on negative sides of using context properties. You can refer to the guideline for this. There's a lot more information. Unfortunately, I wouldn't have time to go into detail about that. And there's one question. The guidelines are at the end of this slide. You'll also see it's on my GitHub account. You can access it there. There's a question about the better use of loader and create object. It's in a lot of cases using the loader is a better idea, even though create object, then there's another type that you can use for this instantiator. But loader manages the lifetime of it, so usually you want to go for loader. And one more question from Emil, and I believe this is going to be the last question. Is the performance worse if we send an HTTP request from QML instead of from C++? I have no insight about this. The sending the HTTP request uses JavaScript's own fetch API, as far as I'm aware, but I'm not familiar with the performance effect of using the proposed solution, so I have no idea. But it'd be nice if somebody took a note and added something to the guidelines. And with that,
great, thank you. Yeah, I think we have to call it a close here, but thank you very much for the great information here, Farkhan. So appreciate you all joining us today. Look forward to seeing you at another session in the next day or so. If you'd like to join our live chat, the Professional Services Organization is live on the live event portal. If you have other questions or would like to talk about other things as you use Qt. Thanks for joining us, and thanks to our presenter today. Thanks, Farkhan.
Thank you, Nikki.